Hi, let's talk a little bit about different ways that we can read and write chemical reactions. So I have this chemical reaction. Quintessential is the reaction for water. There are really three ways that we can represent this. We can represent it with words, so sentence, I'm talking it out. We could do what's called a skeleton equation. That's when it's not balanced. And then lastly, the most important one is balanced chemical equations. So let's take this. How would you read this? Well, there's a really general way where all you do is say the chemical names. So this would be hydrogen reacts with oxygen to produce water. Okay, so just really easy, basic. Here are the reactants and the product that it produces. Now, to be more specific, we would include the moles for the balanced equation and the phases. So that's how I'd read this to be as explicit as possible. I'd say 2 moles of hydrogen gas react with 1 mole of oxygen gas to yield 2 moles of water in a liquid phase. And so that's showing phases and the moles. Now, a skeleton equation, sometimes you'll want to do this just really quick to get down what are the reactants and products. You can't do any stoichiometry with this, but it will do a brain dump where you can just get reactants and products out. And then sometimes there are questions that it will ask for a skeleton equation, not often, but every once in a while. So here's a skeleton equation. It would be simply writing the reactants and the products. So you see the H2 plus O2 yields H2O. This would be in like a 10-10 class that you would have to do a skeleton, or maybe like an honors chemistry, a general chemistry class in high school. Now, here's where you want to live. This is where you want to get to, that you're always doing balanced chemical equations. And the reason why it's so important to do balanced chemical equations is because that's when you can do math. That's when you can do the stoichiometry. We can't do anything mathematically if we don't have a balanced equation. Because remember, this all comes from the conservation of mass. The amount of substance we begin with is always the amount of substance that we end with. The number of atoms on the reactant side equal the number of atoms on the product side. So here's your balanced equation. It's going to be the 2 moles react with 1 mole of oxygen to produce the 2 moles of H2O. And just as a little reminder, let's count atoms on this. So 2 times 2, I've got 4 hydrogen. So let's write that down. If I do hydrogen here, we have 4 on the reactant side, then 2 times 2, 4 hydrogen on the product side, and then I have 2 oxygen on the reactant side, and 2 times 1, 2. So the number of atoms on the reactant side equal the number of atoms on the product side. And there you have it, 3 different ways how you can speak it, really quick write it in skeleton form, and then most important, and this is what you always want to get to, is that balanced chemical equation. If you're ever given an equation that's not balanced, first thing you do is balance it, and then you do the rest of the problem. All right, have a good day. If you need help balancing, check out those videos. Thanks so much. Bye.